Hey, and welcome back. So now we are starting 3-point perspective studies. So what I want to do today is demonstrate, show you, and have you practice the 3-point perspective setup. 3-point perspective is about the setup or the arrangement of 90-degree triangles and how they overlap to find our very important aspects that we need to set up an accurate and measured at times 3-point perspective drawing. So the 4 things that we're going to be looking for. We're going to be looking for number 1, a vertical station point. We're going to be looking for a left vanishing point and a right vanishing point. That should be actually 2 and 3. Let me erase that out a little bit so we have that. So left vanishing point. There we go. And a right vanishing point. And lastly, a vertical vanishing point where we have diminishment coming from our height now as well. That's going to be very important. So let's get started. I want to get our setup in. I'm going to measure 3 inches down from the top of my paper. My paper is a little smaller for these lessons. It's 14 by 17. So I'm just going to keep my horizon lines for these demos at 3 inches across. So I measured 3 inches and just drew down, okay? And I found my center of vision, since I'm 17 across, that will be at 8.5 inches. All right, so now you're probably asking me, okay, why is the center of vision now, the horizon line, which I'll label over here, so high up? Well, we're going to be studying today bird's eye view and also worm's eye view 3-point perspective. Now, because we're going to start out with bird's eye view, we're going to be higher looking down on the ground plane. We're going to be tilted. Our head will be tilted, so we're going to be looking downward. And that's the whole point of 3-point perspective, is to demonstrate and show the relationship now to head tilts, looking up at or looking down upon an object. Okay, and we're going to do that with 3 examples from bird's eye view. So I'm going to put over here at the top here also BEV, that's bird's eye view. Bird's eye view, and we're going to do this first drawing with a 20-degree head tilt. Here's my center of vision, here's my horizon line, and then we'll start with our head tilt. So you need to get these 4 relationships working together. 1, 2, 3, and 4. Vertical station point, also eye level, those are the same. I'll show you why that's going to be different from the horizon line. Left vanishing point, right vanishing point, and vertical vanishing point. They all relate together. 3 of those can be random. You can find them any way you want, but when you find the 4th one, that has to be locked in by some other relationship, and it locks all of them in. They work together, but they can be found randomly at first and then locked in. So let me start out by showing you how I like to set things up, because I like to get my rate of tilt. So we want a 20-degree tilt in this demonstration of a cube. So here I am at 0 degrees. I've got my protractor upside down. This is 0, this is 90. And so I'll come over at 20 right here, make a mark, and I'm just going to throw out a diagonal line right in through here. Throw it on out. That represents 20-degree tilt, okay? Anywhere along this line that I want to put our eye level. So there's our tilt. Let's get number 1. Let's get eye level and vertical station point. Let's get it about right here. So I'm going to draw a light line. For you, draw really light. I've got to draw a little darker so you can see it. Right there where they touch, that's your vertical station point. Your eye level has now moved off the horizon line at 20 degrees. So there's your VST. I'll label that VST, and remember, that's our little U now. We have a different station point flapped over in 3-point. So we're flapped over to the right, or if you wanted to the left, you could do it that way too as well. So remember, we flap ourselves up, 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 up until our new center point, which is here, and that will be our relationship looking in. Of course, we'll find our cone of vision in a little bit. Okay, so we've got number 1. That's number 1. Our next step is we want to find our vertical vanishing point. I think it's probably smart to find it now. The vertical vanishing point is found from the horizon line center point aligning like a construction line through the vertical station point and then coming down at 90-degree relationship, 90 degrees. So I set my ruler up, my 90-degree angle at the horizon line center point to the vertical station point, down at 90 till it touches the vertical vanishing point, or this is our center of vision. This now becomes our vertical vanishing point, if you will, or our VVP. Very important. So this relationship right here, bingo, 90 degrees. 90-degree triangulation. We have it there. We also have it here. Remember, this now becomes our degree of tilt, right, which is 20 degrees. Remember, we're going to be 20 degrees looking down upon a box form in this case. All right, so our next problem, we have our vertical station point. We have our vertical vanishing point. We need a left and right vanishing point. You can pick it anywhere you want. I could pick it way out here or way in here. I want to be reasonable to get it in the camera. So I'm just going to randomly pick a left vanishing point. I'm just going to throw it about right here. So I'll put a dot and we'll label that LVP for left vanishing point. From that left vanishing point, we need to come down and we need a construction line to come through our vertical vanishing point. We need that to come down. So we bring down a construction line, which helps us find our right vanishing point. We need a 90-degree relationship from the LVP and the construction line to the VVP out to the right vanishing point, because we've got 3 of our four 3-point setups. We need one more. We need the right vanishing point. That's got to be locked in. It's got to be given. So along the construction line of our line from our vertical vanishing point to our left vanishing point, we'll line up our triangle 90 degrees, move up, slide along it till it comes right through the center point of our eye level. There we stop. We come through that point at 90 all the way to the horizon line. The horizon line, remember that, where it touches, that is our right vanishing point. Okay, that's a 90-degree relationship right there. That's another one right there. I want you to get in the habit also of checking it and improving it along the other side. So a construction line from the right vanishing point through the vertical vanishing point here. Then we line up our triangle at 90 through the center point of our eye line, our eye level, excuse me. We line them up and we find that we are right on the left vanishing point, which is exactly where we want to be. And so we have a 90-degree relationship right there to find out. So now we have everything we need. We have a left vanishing point, a right vanishing point, a vertical vanishing point to set up our dimension of our height, or diminishment of our height, and we have the vertical station point and eye level as well. So we're all set up. Let's go ahead and draw in our cone. Let me show you to make sure you know how to get your cone in. So you need your compass and your 30, 60, 90. So we want to put in the cone now from our little U, the vertical station point. You've done this in 1 and 2 point. Okay, through here, 30 degrees, right? I'll make a mark there so I know where to put my compass, and also 30 degrees here. Remember, what happens outside the cone of vision is distortion. It even gets, I think, even much more shrunk in 3-point perspective. I think distortion starts to happen inside the cone even. We're probably better off with a smaller cone of about 30 degrees, but we'll keep it with our 60-degree cone. So I have our cone here, and then we'll set in there, get our compass, our trusty compass, way overshot. I'll get it set back in. There we go, right to there. That looks good. Then we'll throw in our line. A little off there, let's go. Okay, no big deal. In through there, and now we have our cone of vision as we get our setup. So we've got everything we need now. We know where our distortion happens. We know where our cone of vision is. We're better off if we don't want a distortion. Then I'll come in a little bit. Let's pull in and let's draw a nice 3-point cube in bird's eye view at a 20-degree tilt. So the first thing we want is we'll lay down a line of diminishment to the vertical vanishing point. So remember, no verticals are truly vertical unless you're completely lined up on your center of vision. That's important. So we'll lay in a vertical diminishment here, right along there, and then we'll say, I'll overlap this now with a blue pencil to say where we want to end this length of our box for. I'll say about right in through here in blue. So we have that there. Then I can throw out diminishments to the left vanishing point, here and here to the top and bottom of the corner of the box, and also now to the right vanishing point here and also there. We're good to go there. Now I can cut off my box. I'll try to make it as cube-like as possible in 3 points, so about right here. So now back to the vertical vanishing point. That's where our diminishment is, from our VVP up to and ending right along those diminishment lines right there. Okay, and then we trace over that nice and clean here and also here. So we have the left plane of our box, level box in 3-point perspective looking down at 20 degrees. We know that because we've locked in our degrees. So now from the vertical vanishing point, can't see it off camera, I'm just lining up from the VVP out to now and I'll make this a little bit longer on the right side for this one, just to give a little bit of dimension there. So projection here, where they touch our diminishment lines for our plane. I'll overlap in dark here in blue so you can see that. Here and here, bingo. And then of course this becomes a 2-point drawing problem. Let me get that better there for you. There we go. And then from this corner we go back to the right vanishing point here, excuse me, left vanishing point there, and also to the right vanishing point here on the other side. We're good to go. Of course, where they overlap, there goes my pencil, that becomes your back corner of your box. And of course we can draw this one inside out and through here, so I can project from here back to the left vanishing point, bingo, back here, left corner back to the right vanishing point there, and let me get that lined up better. There we go. That's good. And then from the vertical vanishing point up, and you see those lock corners together, and there we go. We've got your first nice 3-point perspective box now looking down at 20 degrees. So the accuracy of that is proven. We're looking down at 20. We also got our 20 degrees with our protractor, and we found all of our 4 areas to hit. We found our left vanishing point, our right vanishing point, our vertical station point, which is also our eye line, and also our vertical vanishing point down here. If I come out just a little bit, all together to set up our 3-point perspective box at 20 degrees looking down. All right, so the next one I want to do one at 20, one at 45, and then one about 65. So we'll go on to the next little diagram here, and we'll go now to a 45-degree view of a 3-point box. And you're going to notice what's going to happen to the relationship to these 90-degree triangles. Are going to start changing, and we're going to start seeing this vertical vanishing point start to go higher, and we're going to get steeper views. The angles of these lines coming in are going to get steeper and steeper. It's going to be pretty, hopefully for you, fascinating to watch this transformation happen. Okay, we'll be right back with the next one. Okay, let's do setup number 2 now in bird's eye view. So I'm going to put the horizon line again at 3 inches down from the top. My paper is at 14 by 17. Nothing has changed. Okay, so 3 inches down, we'll put the horizon line, label everything, reinforce everything for yourself. Now we'll put the center of vision again at 8.5 inches in, just to the center of the paper I'm using, and we'll draw a line for a center of vision. So the more you do, the more familiar you get with this setup, and then later on you can relax it. You find your points for your vertical vanishing point, your left and right vanishing point. And you can blow up a drawing any size that you want. So you can keep your 3-point relationship small, and then when you get your points, you can multiply them how big you want. It's pretty fun to do. Okay, so for this drawing, obviously we're going to need the vertical vanishing point. We're going to need the left vanishing point. We're going to need the right vanishing point, and obviously we're going to need the vertical station point and our eye level. Okay, for this drawing it will be bird's eye view, and we're going to be 45 degrees now in a tilt looking down. So one of the easiest ways to make a 45 degree view is to take your 45 degree angle from one of your triangles and just line it up like this. Put one of the 45s out along the angled line here, and then draw a tilted line down. Now you can do it in different ways. I'm probably better off showing you how random 3 of the 4 can be, but I really like to get the tilt in first. That's just how I like to do it. Other artists might do it differently. So this is 45 degree tilt. Okay, so we know we got our 45 degree tilt, and now we can set in our eye level anywhere really along this angled line. We can just mark it with a straight line. The only thing I have to think about compositionally is make sure I get it in the composition. So what I'm going to do is we'll put it a little bit lower down, and so we know it's going to be a 90 degree angle, so I'm going to put it about right. I want to keep it in my camera, so I'm going to have to pull out my camera just a little bit. Here we go, and I'll bring this up, make sure you can see everything. It seems like it's tough, but if you can really begin to just reinforce the mechanics, you'll get it in no time. So we're going to put our eye line about right here, right, and that makes, number 1, my eye line. This also makes my vertical station point, which is our little person there, right? There's your head and your feet, okay? So that's us flat down, okay? Now this rate of tilt that we know is now 45 degrees. So look how far off we are from the horizon line. Compare it to your last drawing. Okay, so how do we find our vertical vanishing point? Because we have number 1 right here. We have our vertical station point and our eye level. We need to find our next one. So the relationship of 90 degrees from this line at 90, which I call the rate of tilt here, from the horizon line center point through the vertical station point, stop where it reaches the 90, then come back over to the center of vision here. It's our CV down here. That, where they touch, that creates your vertical vanishing point. Remember, that's where all our diminishment comes to. Very important. So we have number 2. Now we need 3 and we need 4. So now I'm going to change it up a little bit. Let's go for the right vanishing point. So I'll put my right vanishing point. That still can be random. It could be here, it could be over here. I'm going to put it about right here. So there's my RVP, right vanishing point, along the horizon line. Must be on the horizon line, okay? That hasn't changed. So that gives us 3 of the 4. And now we need our left vanishing point. How do we find it? Pretty easy. Construction line from the right vanishing point through to the vertical vanishing point. Okay, all the way through. Remember, 90 degree relationships. Okay, so we line up our 90 degree angle on that construction line. That helps us find that. Then we're going to line up, go through the center point of our eye level. Okay, we're going to come through 90 degrees here, line that up, come all the way out to the horizon line. All the way out. Hopefully I keep it on camera. Yeah, just barely. Woo. Right there. That is your left vanishing point. That's given. Now we've got it. We had to have the right vanishing point. This was 90 degree relationship right there. Okay, at 90 degrees. We had to have it from the right vanishing point. We drew that construction line back, and then we lined up at 90 along that construction line. It has to go through your eye level, center point there. Right there, eye level center point. Once we do that, we draw back to the horizon line to get our left vanishing point. Now let's prove it the opposite way. Get in the habit of doing that for a while, for especially my students at NKU. Through the left vanishing point, bingo, back to the vertical vanishing point. That's our construction line. And remember, 90 degrees, we're just doing it the opposite way. Here, vertical vanishing point, line up our triangle at 90 along that construction line through the center points of our eye level, and see how it lines right up right there. There we go. Bingo, right on through. There's your 90-degree relationship. Here, and of course also right there. Now you have everything you need to have your setup. What's important? What's really important? Our LVP, right? Our RVP, and our vertical vanishing point. Now, what if you wanted to blow these three relationship areas, we'll just call them dots, up 3 times? Well, instead of redoing it on a big piece of paper, all you have to do is measure their space between and blow that up. So if they're 10 inches, 12 inches, whatever times 3, their ratio stays the same, and you can blow it up and you can draw really, really big and do a final drawing, especially if you're keeping your drawing ultra light. Mine, again, is darker because it's got to be darker to get it on camera to show up, but yours should be baby, baby light. Okay, we need our cone. Let's get our cone in. Remember 30, 60, excuse me, we need 30 and 30 on either side to get our 60. All right, so we take our 30-degree angle here, we line it along our eye line to our vertical station point, out 30 degrees, make a mark there, out at 30, and we'll do it on the other side so we can get that cone set in, so we can see where. This really tells you where your distortion is for sure, everything outside of that. So this might be enough, but let's go ahead and use our compass and get that laid in. So I'll take my compass now and we'll get our cone of vision set in. Here, lay it along the eye line center point against that degree out there. We've got our cone set out. It's pretty good. There we go. And so I pulled our station point out a little further. Our vertical station point out a little bit further. If we were closer to the horizon line, we could be here, okay? And that's still at 45 degrees. We're just a little bit closer to the horizon line. The further I go along this 45-degree mark later on and put my eye line, we're further back, and that would open up our cone. So we could slide across there. All right, so now we're ready to set out our box. So let's put a box and we'll put it in our cone of vision here. Let me see if I can come in a little bit so you can get a little clearer. There we go. All right, so now I could set up vertically first, or I could set my rate, my left plane first if I want. Let's just do that so we can just do a little bit different things. So I might start there, and then we can come back to our vertical vanishing point, project up like that if we want, and then I might cut it off right here. Now we're off center. Here's our center of vision. So it's going to be, these things are going to start to tilt, and you're going to get distortion a little bit. That's accurate. All right, so we'll go back to our left vanishing point here. I'll shoot out here. So the front corner of the box will end it here. Line up through the vertical vanishing point right through there. There we go. Now I can project back to the right vanishing point. So in 3-point perspective, there's no true vertical except for along the center of vision, and that's the only place. That's very different than 1-point and 2-point. Verticals are always true 90 as long as they're level. That's something to remember, okay? So this will never have vertical lines unless you just happen to be right on our center of vision. In this case, I didn't want to be. All right, so let's project again to get some depth of the left plane about right here. There we go. And also our right plane on the other side, maybe about right, maybe a little bit wider out here. There we go, right there. And I'm going to stop where they meet the diminishment planes. And then I'll draw back over in darker blue here and also there. And we'll finish those planes out. So remember, we're going to be looking down in a box at 45 degrees tilt in bird's eye view, meaning that we are looking down to this box here. And of course we don't have a scale, so we don't know if this is a building or if it's a tiny little Lego. We just know that's an accurate view of what we're looking at here. And we'll come back now and finish this out right through there. Whoops, let me get a little bit more accurate. So I sketch it through. And we'll finish this out here. We've already got our top plane of our box in through here, and let's go ahead and finish the back end of it too as we see through it. So I'll come through the vertical vanishing point here, down to get some diminishment there. It's just about lines up with the back corner just a little bit there. Left vanishing point out and through, and then of course right vanishing point right and through. And where they meet up, boom, there is the back of our box. So now we're at 45 degrees now, looking down onto this box. So we got everything we needed. We found our vertical vanishing point, our left vanishing point, right vanishing point, and our vertical station point, which is also on and at our eye level. Then we projected our cone at 60 degrees, 60-degree cone from our vertical station point, 30 and 30, remember that. So this is 30 degrees here. This is also 30 degrees in our cone here, and also bingo, which gives us a total degree projection of 60 degrees running through there. And then of course we threw our box and through here. Remember, our tilt was 45 degrees, so that's how you find, your tilt, or you can measure it from here. I like to do it from here, and I like to do it first, almost always. Okay, so there we go. That's our second diagram in bird's eye view at 45. The next diagram we do will be bird's eye view at about 65 degrees. Now, I want you to compare something. So I've got mine underneath. Take a look at this box, and let me come in a little closer so we can see that a little bit better. Take a look at now, we're getting a steeper view. Something I want to show you. Now, our eye level is higher up. We could have put it out here, which would have been fine. This would have pushed the vertical vanishing point even lower. But there's a good distance between the VVP and the center point eye level. Okay? The further that is away from one another, the less steep these lines will be. That means we're in a less tilt. We only have 20 degrees. Now, compare that one to this one. Take a look at that. The vertical vanishing point, which bring back out just a little, there we go, is starting to get closer. Why? Because we're at a stronger degree tilt. We're looking down on further. So what's happening is the vertical vanishing point is creeping up to our center point level, eye line center point, thus making these angles more steep and more distorted, if you will, or flayed out even further. Now our next one, this was at 45. This one is at 20. Look at the difference between those. Compare it in your own notes. And the next one we're going to do is going to be at 65 degrees. Okay, let's go on now to that one, to diagram number 3, bird's eye view. Okay, let's go now to bird's eye view, looking down in the box at 65 degrees. So I'll put the horizon line 3 inches down like before. Okay, let's do that. 3 inches down, label that horizon line. There we go. Center of vision right in the middle. It's 8.5 inches over. And then we'll lay our center of vision line down. Nice and true 90. There we go, all the way through. There we go. All right, so we have our horizon line, our center of vision line here, okay? And we're going to be bird's eye view, BEV, and we're going to be 65 degrees. And of course we need our left vanishing point, we need our right vanishing point, we need our vertical vanishing point, and of course we need our vertical station point, which is, excuse me, along our eye line. Once we have all that, and they're interrelated, okay, they're interlocked in. 3 of those can be random, but the 4th one will be given. It will be locked in, and you can't change that. All right, so the first thing I want to do is I like to, again, get my degree of tilt so I know. And we said 65 degrees. right? So let's get that in. So I'll lay down my protractor, line that up. I'm just lining it up here at the center point in this middle line here, right through there, at 0 here, 90 there, and then I come along at 60. I find 60, I make a nice clean mark so I can see that, and then I know I can project outward at 60 degrees for a tilt, right in through there. Okay, from the horizon line center point. So out, that's going to be at 60 degrees. Okay, so that's 60 degrees. That's going to be our 60-degree tilt. Now I can say how far close to the horizon line I want to be or further out I want to be for my eye level. And one thing I do compositionally, I know it's going to be a 90-degree relationship. So if I have a 90-degree angle, I can set it out and see how far I want to be within the picture frame too as well. So that helps as well. So about right in through there, I'll keep it. So I'm going to make mine about this long. So it's a 90-degree relationship from the horizon line center point down to where you want your vertical station point, right there, and back across. That also gives you your vertical vanishing point. They relate at 90 degrees. So that's a 90-degree mark right in through there. That also tells us that that's where our eye line, eye level will be right across here. We'll draw a nice clean line across. There's our eye level. Here's our vertical station point there, and then there's our little bitty person of us. Remember, right through the center of between our two eyes, right in through there. And what tilt do we have? We have now a good 65-degree tilt. So this will come more important. I remember when I was a student, I just did this over and over and over again. I kept a sketchbook and did that a lot, and it just became second nature. If you don't use it for a while, you might forget a little bit, but you just find your notes and you catch it pretty quick. So we've got 2 of our 4. We've got our vertical station point, our eye level, our vertical vanishing point. We need a left and right. One can be random, the other can be locked in. Here's another way you can find it. You can say, hey, I want to kind of feel this angle out. So maybe, I know my cone is probably going to be somewhere out here. So maybe I could feel it, if I wanted to go in the space a little bit, maybe I could start to feel the angle this way, or feel the angle, shoot for it that way. And so I might say, okay, here's where I want my left vanishing point by projecting where I think I want my cube to be, right around through there. And where that touches, there's your LVP. And of course you could have done that to the right vanishing point as well. So there's your left vanishing point. So we've got there. One more to go. We need a construction line. Remember, from the left vanishing point, draw a construction line through the vertical vanishing point. Okay. Then remember our 90-degree mantra. Things relate at 90 degrees, and so we'll set that up along that construction line. We slide over until they relate and meet up right through the center point eye line, all the way over through and then to the horizon line where it touches over here. That gives you your right. Your RVP, your right vanishing point. So there you go. So that's a 90-degree relationship. And then prove it by doing the opposite always. Get that down. Right vanishing point through the vertical vanishing point, you need a construction line, right? And through that point, construction line through eye level center point, line them up to the left vanishing point along the construction line, and there's your 90-degree relationship right there. So you can prove that this is all working together for you. And of course, there's 90 there. There's 90, and of course, this now is at 65 degrees like we want it to be a bird's eye. So we've got everything we need. We are good to go, and we're cooking. Okay, so, well, we need our cone, don't we? Okay, we forgot our cone. Let's do our cone. Can't forget our good cone here. Okay, you can leave the cone out as long as you can kind of figure out where your distortion is, but let's put it in. Let's put our cone in. Now, I had a student the other day at NKU. We had it so deep. We were at 70, 75, 80, and I'm going to project my cone and I'll show you. This cone, I'm going to draw it pretty dark too. This cone is the vertical vanishing point is just going to reach inside the cone. That can happen. As a matter of fact, the vertical vanishing point can meet up to the eye line center point, and when they meet up, that becomes 1 point perspective again, right in through there. There we go. So there's our other side of our cone right there. So see how the vertical vanishing point's way down here. Can you see it? See how the vertical vanishing point is just going to be inside the cone just a little bit. So let me pull this up a little bit so we can see that the horizon line, as long as I'm showing a little bit, we'll be fine. There we go. So see how the vertical vanishing point now is going to be just inside the cone a little bit. That's totally fine. That's totally okay. There we go. There's where our cone edge is. Right through there, coming through our cone. There we go. Now we've got our cone set in, so we know where our distortion happens, and it happens fast in 3-point. We're probably better off with about a 30, maybe even about a 15 or 20 degree cone. It doesn't take much. Okay, so we can now project. We've got our we already have one 2-point plane angle, so let's play off that, and let's put a box here from our vertical vanishing point. Let's get our diminishment for our height. Let's go up to, let's say, right there. I'll cut it off about right there. Outline it in blue so we can see it a little bit stronger there. There we go, nice and strong. There we go. And then we'll get our left plane from the bottom of the box down through here, and then we go to the right vanishing points. There we go. Here, I'll just draw towards it. I need to go all the way back. And there we're good to go. And so now it becomes a design problem. Where do you want to cut it off at? Well, I'll just cut it off at, let's say, about right here. And look at that rate of diminishment. Boy, it starts to get really strong, doesn't it? It starts to be more like a skyscraper. So if we overlap here and draw this in blue now, look at that left plane really reacting to how close that vertical vanishing point now becomes with a 65-degree tilted angle. Okay, so let's draw the other side. From the vertical vanishing point, I'll project out a little bit wider, maybe to here, like so. Okay, and then I'll tighten up and show you that in blue. Here and to there. There we go, and also to there. Right. So take a look at that, and then we just, to finish out the box proper here, the outside part of it, we'll go back to the left vanishing point here, of course, and then from the other corner, go back to the right vanishing point from the left corner, basically just go opposite. Where they meet, of course, becomes the top of the box. There we go. And let's finish the inside a little bit. So from the corner, we'll have our rate of diminishment through our vertical vanishing points, or vertical diminishment now. Through here, remember that, vertical diminishment, we have 3 places to shoot to. Left, right, and vertical. So we'll shoot out here a little bit, and then from this corner, shoot back to the right vanishing point. Boom. Where they meet up, right there, is our corner. There we go. So it's a corner of our boxy form is a little bit off there. That's okay, pretty close. Going pretty fast with these pencils, but you get the idea. Right in through there. There we go. So now we have a 65-degree tilt in our box relationship. Now, a couple things to point out. So we understand our tilt. We're 65 degrees looking downward. So we're at where our head is tilted far, far greater now than 45. So we have 65, we have 45 here, right? And then we have 20 degree up here. Let me bring that down a little bit so you can see that. It's a bit better. So now we have 20 degree there. Look at the difference between the relationship of the look of the box first. That's important. So 20, 45, and then 65. Okay, we're looking far greater down on it. Our head is tilted far greater. Also notice where the VVP is now, the vertical vanishing point. Look how much higher it is now. Now it creeps inside the cone even further. So the closer the vertical vanishing point is to our center, eyeline center point, these projections are going to get much more steep, okay? I won't say distorted because that's accurate, but they're going to get steeper and steeper as we go through. Then we come over here and we see at 45 degrees, right? This is further pushed back from our center point of our eye line, further back. So these angles become less steep. We see a little bit less of the top than we did here. This becomes a lot flatter. And then when we get to 20 degrees, projection, right, we start to see even less at the top, and we get closer to the eye level as well. So these angles become a little bit straighter as their vertical vanishing point becomes further and further away. Really important relationships to begin to understand and to begin to master as you want to go through 3-point perspective. So there we go. So those were 3 setups in bird's eye. We had bird's eye view 20, bird's eye view 45, and also bird's eye view at 60 degrees. So we're also, remember, we need now to understand a relationship that happened between our 4 important areas that we need to set up. We had to determine and get a left vanishing point, a right vanishing point, right? We also had to get a vertical station point, which is also at eye level, our point on that eye level, and also our vertical vanishing point. Remember, any 3 of those can be random. When we choose the 4th one, it locks everything in together. That's what's really important about that, and important to understand in our 3-point setup. The 3-point setup. Very important lecture here, diagrammatically speaking, on how to get these relationships. It governs everything else you want to do in 3-point. Okay, let's go on now to worm's eye view, WEV, and we'll do 20, 45, and 65 in worm's eye view. Okay? Now, one little tip before you leave, one little cool thing. If you want to see what worm's eye view looks like, just take any one of your drawings, right, and flip it upside down. Bingo. There you go. Take a look at that. So there's a box in worm's eye view. All right? Okay, and that's what we're going to do next. We're going to do the same setup, but we're going to set it up for worm's eye view. All right, so stay tuned. I'll be right back, and we'll rock and roll those. Okay, so here we are now with the next set of setup diagrams in worm's eye view. Now we're going to be, on the ground looking up at a box or objects, and our head's going to be tilted. We're going to do 3. We're going to do one at 20 degrees, one at 45, and then one at 65 degrees looking up at. Remember, our head is tilted now, so our eyes are going to be off our horizon line. That's going to be very important for you to remember. That's the big key component of 3-point perspective. So I'm going to place the horizon line for these drawings lower. So I'm going to put them 4 inches down from the edge of my paper out, 4 inches down and out, and then I'll obviously draw my horizon line, and we'll get our setup here. Label that horizon line, and then we'll put our center point in the middle. It could be pushed over a little bit, and of course, because we push down our horizon line, but still where they come together is your center point. 8.5 inches, because I've got a 14 by 17 sheet of paper. All right, and now we'll put our center of vision up. We'll project that up and a little bit down here and all the way up and through, so we have a relatively good amount of space to work with. Now, the first thing I like to set in, again, as always, for me, and you can start anywhere you want. You could get your vertical vanishing point, your left vanishing point, but I prefer to know my rate of tilt. I think that's, for me, it's important. And so I'm going to start with a tilt, and then instead of just guessing at it, I can take my protractor, and let me come in close so you can really see this nice and close how I set this up. If you've never used a protractor in any real meaningful way, this is good. So I take the protractor and I set it up here along the corner edge where this line is. Set it up right in through there, get it level at 90 or set it 90, and then 0 over here, and then I can start to come along these movements, and since we're working from 0, I can set in 20 right in through here. Now if we were setting at 0 here, it'd be 160, but I'll mark in at 20, and so now I know that I'll have an angle tilt at 20 degrees. So I can come out and project from our center point here, where our center vision and our horizon line meet, and that gives me now our nice angle. So I'll just throw out an angle there, and remember that's 20 degrees. That's a 20 degree tilt. So we're off our eye line is going to be anywhere along this line where we draw it from, and that's going to give us a 20-degree tilt. Now, the further we're out here, the higher up the vertical vanishing goes. So it gives us further and further away where our cone opens up even higher. All right, so let that sink in. I'll grab a cup of coffee here. Okay, and let's put, let me pull out now just a little bit so we can see this. There we go. That's important. Coming on out, coming on out. There we go. Okay, I'll get set in a little bit centered. Back again. There we go. All right, so let's set in the eye line now. And I kind of have to be careful. We've done this, you've done this enough to know that wherever we set in our eye line, where we bisect with our line, or we can just put a dot there for our vertical station point. Remember, we're going to be 90 through the center point here to where our vertical station point is, up to our vertical vanishing point. So sometimes I forget how big or small my paper is, and I'll set something out here, and then I'll be way out of screen. So I'm going to try to just already kind of figure how high I want to go, and I think I'll be in screen there. So that feels pretty good. So I'm going to put a dot right there, and that's going to be our VST, and then quickly I'll just move to draw a line across. That's our eye line. So now we have our eye line right in through here. So I will label that eye line. There's our vertical station point right in through here. I'll label it VST. That's our little bitty person, our us, flapped over. There's the head and shoulders there. So there we are. Remember, we're flapped over now. If we flap back over, we'll be looking into the scenario here. And of course, that is where our new center point will be. Okay, we could go ahead and get our cone. I'll go ahead and do that and get our cone in at 30 and 30. Right, so we're here, and then we line up our 30 degrees. This should be familiar and easier for you now, like you're going through all the lessons. If you're kind of skipping through 1 and 2 point, that's okay. I mean, you can control what you do, but you want to go back and know how to get your fundamental 4 and Y. That's important. So there we go. So there's our 30-degree cone there. And then I'll take my compass and we'll get that laid in pretty quickly. Adjust this where we need. There we go. Right there's our 30 and 30, our 60-degree cone. So we'll be in here. That's where we get less distortion in our drawing. Okay. So we have that. Now, let's go ahead and capture our vertical vanishing point. Remember now, 90 degrees from our horizon line center point, right, through our vertical station point out to, so we're at 90 here. Did I miss it again? Let's see. There we go. No, I got it in. Okay, woo, just barely. All right, so from our center point through our vertical station point, that's a 90-degree relationship right there. And then we turn up where we meet our center of vision, where that touches, right, is our vertical vanishing point, okay? Since our angle of tilt is so low at 20 degrees, we're tilted off the horizon line, now at 20, right? That will put that VVP up pretty high. Now, we've got the right vanishing point and the left vanishing point to deal with. One of those two can be random. Let's set in the right vanishing point first. So I'll come down and say, okay, I think I want my RVP here. So we've got our RVP. So we've got 3 of the 4 things that we need, right? So let's label it here. We've got our vertical station point and our eye level. We've got our vertical vanishing point, which gives us our rate of diminishment for our heights, our depths, okay? We also have now our right vanishing point, and of course now we're missing one, which is our LVP, our left vanishing point. So let's get that. In order to do that, we need a little help. Remember, so from the right vanishing point, construction line through the vertical vanishing point, right? Then from that construction line, we go through our new center point on our eye level at 90. So we line up construction line here, we go up, doom, 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 and we move, and then we go right through our eye level center point, our new center point at 90 degrees, out to and through the eye level center point to our horizon line, and that gives us our left vanishing point. So now we have everything we need to work with. So this relationship here is 90 degrees. Okay, important to know. This relationship here is at 90, right in through there, correct? And now we need to find, even though we've got everything we need, I want to continue to show you. Let's do this work and prove it that this works. Vertical vanishing point construction line through our left vanishing point, then through our construction line back through our center point of our new eye level. We'll go back, and that gives us, see, that gives us right to our right vanishing point. So we can say, there we are, and we've completed that fullness that we want, and that gives us another right angle relationship right in through there. So we're good to go there. Very important now to see those relationships. So let's draw now a 3-point box with a 15-degree head tilt. We're looking up now at our image. Let me write that down. So we have 20 degrees tilt, and we're in worm's eye view. Okay, so we might start out and say, okay, I want through my VVP up here, right? I want maybe this type of diminishment about running through here. So I'll draw a longer line out, and I'll say, okay, we want it about right here. Now we're going to be close to the horizon line, which is fine. And I'll say, okay, I want to end that box maybe about right here and here. So this is the corner, the front corner of the box, kind of in 2-point, okay? Even though we've projected our vertical to the vertical vanishing point. Now I'll project depth from the back to the left vanishing point here and along the bottom corner, there and there. So we're moving along, and I think I'll come in a little bit so you can see that better. There we go. Nice and close, better. Move this up a little bit so you can see that. There we go. And then we'll project back to our right vanishing point here. Okay. And through here. Once you get the 3, you've got it. And of course you've got your vertical station point, so you can set your diminishment in your cone of vision actually. Alright, so let's figure out how long we want to make this box. I think I'll make it about this long. So I'll just put a dot there to tell you how far I'm going to make it, or I could just draw back to the left vanishing point here. And now from the vertical vanishing point, we project from the VVP up and then downward. Again, where they bisect, right in through here, that's the left plane now in 3-point, and then we'll go back to our left vanishing point here to finish it out. Okay. Same thing now with our right plane. How far do we want to cut it off? I'll draw a little bit longer here. Put a dot there and just draw over that line, fill it in, and then from the from the vertical vanishing point up high, our VVP up here, right? I'll just project downwards. That gives us our rate of diminishment. Remember, once you get your 3 setups, your VVP, your vertical vanishing point, your left and right vanishing point, you're locked in to your composition where you want in terms of where you go. So I just draw over that now. Now we need to see the bottom of this box. It's going to be slight because it's close to the horizon line. So we can project to the left vanishing point here. And then we can project back to the right vanishing point from here. Where they touch, bingo, there is that very slight bottom of that box now at 20 degrees. So there we are, bingo. And if you want to make this, we can see through it, which I think is important to see. So we'll go from this back right here, or the right corner here, back to the left. Same thing to the right here, back from the left corner to the right. And then through this point, through the VVP, we get back and touch our corner there, and there we go. So now we have a box at again, a 20-degree tilt in worm's eye view. Perfect vision of how we see, and of course we're here, and we flap ourselves up to our new center point, and we're looking through at what could be a building or whatever. You could turn this into flying spaceship or whatnot. Okay, all right, let's go on to the next diagram, and that will be worm's eye view at 45 degrees. Okay, let's do that. All right, here we go. So we're gonna do worm's eye at now 45 degrees. So let me pull out a little bit. So I've got the other drawing underneath a new sheet, so we can we'll compare those a little later on if you want. There we go. That looks pretty good. So I'm gonna measure again from the bottom of my piece of paper, slightly in screen here, 4 inches up from the bottom to catch our horizon line right there. Just put a mark there, and then straight on over. You got this right there, and then of course that's labeled horizon line, and our center of vision is right on down the middle of 8.5 inches in. And let's go ahead and put our center of vision up. The more you do the setup, the easier it gets, and then you can start to really begin to be more creative with your projects and your understanding and knowledge. All right, so there's our center of vision. I'll label it down here, and then remember we need our 4 fundamentals. 1, 2. Well, we're setting up our 4 fundamentals. We also need our 4 points: our vertical vanishing point, our vertical station point, which is our eye line helper, right vanishing point, left vanishing point. Okay, so this time we're going to be in worm's eye view at 45 degrees. So WEV, worm's eye view, and this is going to be 45 degrees. All right, so we're going to be looking up at 45 degrees. Okay, so again, the first thing I like to do is to, for me, get my angle. You can put a right vanishing point first, a vertical vanishing point, a right vanishing point, but it's hard to get that angle how you want it. That's a little tough. And there are a couple ways you can get 45 degrees. Obviously, I can take my protractor, right, and just come over here and say, boom, 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 there's 45, make a dot. Or I can take my 45 degree triangle and say, line it up at the center point along the horizon line, and where that angle comes out at, there they are, this about the same, right? I had to pull that down, but about the same. There's our 45 degree angle right in through there. 2 ways to do it. I like to use the protractor because then I know for sure. Okay, so there we are. Now the next thing we need, we want to get our vertical station point and our eye level. I like to set that in. So we've got our rate of tilt. And so again, I use my 90 because we know that from 90, anywhere along here where we set our eye level, that's going to be 90 degrees back to our vertical vanishing point. So I like to pull this cone out a little bit. The further we pull our station point out, our vertical station point, the longer our cone gets, the bigger our cone gets, which is nice. So I'm going to put our eye line about right here, okay? That's also our vertical station point. Then I come across here and I'll just catch the eye line here, draw it over, eye line, and now this is our rate of our 45 degree tilt. So now our eyes are shooting up, our head's shooting back, and we're up 45 degrees. It's getting pretty steep, okay? Vertical station point, here we are. Here's our little person right in through there, our little shoulders, our little butt, our little head. There we go. 45 degrees up, excuse me, 90 degrees up, sorry, 90 degrees up. That's our 90 degree relationship. Up to our center of vision where they touch. There's our VVP. So we've got 2 of what we need. We have our vertical station point, our eye level, right? And then we have our vertical vanishing point, okay? Let's go ahead and put in our cone before we get our left and right vanishing point. Let's go ahead and do that. 30, 30 gives you a 60 degree cone. Should be getting good at this. There's 30 right there. And there's also shooting out now here at, line it up nice and clean as you can, right in through there. A lot of times I'll just do one and use my compass to get the other one. I'm a little bit more accurate that way. Here's our new center point, okay? So we moved it from here up at 45 degrees. That's the new center point there, and now I'm going to lay in my compass there along our cone point, and then come on over and swing it on over. I did pretty good there. That's because I made my marks bigger so they could attach. So now I pushed the eye level out a little bit, and if anywhere along this line is 45, we could do that. That just gives us a little more space with our cone to deal with. Okay, so there's our cone. Now let's put in our left and right vanishing point. I'm going to put the LVP about right here. Okay, label that LVP, and that's number 3. And then we need to find the right vanishing point. We can't just throw it out there. So construction line from the VVP through the left vanishing point. Okay, now remember, along that construction line at 90 degrees, we move, we set it up, and then we move to the center point along the eye level, right through there. Then we draw through at 90 degrees, coming on over, and then we get our right vanishing point way over here. Okay, so there's our RVP. Okay, so there's our right vanishing point. All right, so we've got 90 degrees here, right? We've got 90 degrees here. We've got 90 degrees there. And then let's go ahead let's draw construction from our vertical vanishing point to our right vanishing point over here. Let's go ahead and do this right in through there. And let's prove it to our left vanishing point. So this construction line we're at right along here. We'll move through, not the line between the vertical station point and the vertical vanishing point, from the right vanishing point through the vertical vanishing point. That can get confusing. We're at 90 degrees through on down to the left vanishing point. And that gives us our other 90-degree relationship. Now we're good to go. So check it out. We've got our vertical vanishing point here. We've got our left vanishing point, our right vanishing point, and of course we had a vertical station point. Now these are the 3 points that we start to work with. I think that's important. Okay, let me grab a drink, coffee here, and let's make our 45-degree box. Okay, so let me pull in maybe just a little so we can get closer to see here. And I'll bring this down maybe so you can get the vertical vanishing point in to see that a little. There we go, we can see that. Okay, so I'll shoot to the corner. I'll keep it off the center of vision. You could put it right along here if you want. Maybe I will for this one because you don't get really any diminishment here. So I'm right on our center of vision through the vertical vanishing point. I'll just draw a cone here, or excuse me, a line here. And I'll say I want it to end about right there and there. So I'll just make it in blue now, right along our center of vision. So there is no degree of angle. Okay, now we'll go from these top 2 points back to the left vanishing point. We'll project. Okay, they're going bingo. Whoops, get a little bit cleaner there. That was bad. There we go. Back to the LVP, right in through there. To slow it down a little bit, make sure I get clean lines. Boom, back to the right vanishing point, back there, boom, there we go. Okay, little arrows to show you that. Now we want to cut off the depth of our planes any way you want. I'm going to cut it off about right here, okay, from the vertical vanishing point up and down. I'll overdraw a little bit, so we're going to that point. And then we'll finish out this plane, line it up back to the LVP, or just trace over nice and clean here, and nice and clean here. There we go. Don't get fooled by my mistake line there. Got it loose. All right, so how far do we want to cut it back over through here? Maybe we'll make it look kind of like a cube. I'll make this one a little bit longer, about right there. Okay, that's where I want to cut it off, so I could just say, okay, this plane is going to be that long. There. Then from this corner back to the vertical vanishing point, I'll kind of draw through so you can see it. There's an arrow to show you that. Okay, and then we finish out by tightening up the bottom here. So there's our right plane, and now what we have to do is finish out the bottom, and then we'll draw through it a little bit. So from each opposite corner, right corner back to the LVP here, and then from the left corner back to the right vanishing point here. How easy is that? Once you get your 3 points, you're good to go. Then you can blow them up later and keep their ratio distance and have a big drawing and just sketch in relaxed perspective, which is just a fancy way of saying sketching. And we'll finish this out. There we go. Okay, so now we've got a 45-degree box looking up at worm's eye, right, looking up at 45 degrees. And let's go ahead and see through that, find the back planes. So here's our top, we'll project there. Opposites from this corner back to the right vanishing point. Where they touch is our corner, and they should line up through the corner to the vertical vanishing point pretty nicely. And there you go. So there's a full 6-sided box cube, and you can do anything you want with that later on, which we will. Very nice there. So we're at 45 degrees. So now, take a look at this. So here we are at 45 degrees. Our head is tilted up, 45 degrees. Take a look at the bottom. Look at the relationship with the vertical vanishing point, okay, to the center point here. It's getting shorter. Now, if I flip over and we go back to our 20-degree view, look how far now the vertical vanishing point, I think it's off the page a little bit, vertical vanishing point is to our center point of our eye line. It gets further out. What happens? We get less a degree of tilt, 20 degrees. Also, take a look at a couple things more. The bottom of the box we see less of because our head is tilted less. Also, the diminishment, the verticality of these lines are not so distorted in 3-point. Now as we go further and further, take a look at that. These get even more angled, right, from our 20 degree, and we see more of the bottom. This starts to get, even though it's not flat, starts to get even a little flatter. Those are things that you want to start to notice as you begin to learn the mechanics of 3-point perspective, why they happen, right angle triangulation, which is pretty brilliant. Right, we haven't used 3-point perspective that long in the history of art. It hasn't been around that long, and in how the vertical vanishing point to our center point, long, far out, etc., really works. And then, of course, the vertical vanishing point can dip inside even the cone to make this even more of a severe tilted look. And then, of course, we could go to 90 degrees and go back to having looking straight up or straight down, and have the horizon line back on our eye, even though we might be looking straight up at the sky or straight up at the ground. I've done that in 1-point perspective with a city view, looking straight up and straight down in our perspective studies, so you can go find that video. Okay, let's move on now to a 65-degree cube looking up from worm's eye. All right, here we go. So here we are now with our last diagram for our setups, and we're going to do a worm's eye view looking up at 65 degrees on a box. So I'll set again the horizon line at 4 inches from the bottom of the paper. There's our horizon line, and also the center of vision, the center of our paper at 8.5 inches. If we're at 17 across, that's 8.5. So there's our center of vision there. I'll make it a little bit lower, okay. And so we're going to be now in worm's eye view at 65 degrees looking up. Okay, so remember, we need our 4 attributes. We need our vertical vanishing point, left and right vanishing point, our vertical station point. Okay, so there's a center point on our horizon line. Let's find 65 degrees. So I've got my protractor. I set it up at 0 here and 90 here. Then I look out across this arc here, and I'm looking for 65 right there. There's 65. Look how high angled up that is. So that's going to give us a head tilt looking up at a really staunch 65 degree angle. That's pretty amazing. So there's 65 degrees there, and so we can put our eye line along anywhere. Now, again, to help me keep it in the composition or keep it in the screen, I know that it's where any point I pick here is going to be my vertical station point, right? And I know that's a 90 degree angle over to the center of vision, right? And that's going to give us our vertical vanishing point. So anywhere along there, I can keep it in the camera. If I keep going out, I won't, because I'm looking for where this touches here and here. So I'm going to put it about right here. Okay, so I get a touch here. This is a 90 degree relationship there to there. That gives me my vertical station point and my vertical vanishing point. Because remember, they're at a 90-degree relationship. So let's slow it down. So because we're still memorizing this process, it's really not hard. Once you get it a couple of times, you got it. Because there's our eye line, right? I draw it through here so we can get our new center point in there, right through there, right? So there's our eye line. Here's our vertical station point. That's our little bitty person right in there. Shoulders, little butt, feet, right there, and we're good to go. So 90 degrees, and of course we're 90 degrees here as well. Now we're pushed up at 65. So this is a nice 65-degree tilt. Okay. Of course, we have our VVP now, vertical vanishing point, right in through there. So let's go ahead and set in our cone, see what that looks like. So we're 30 and 30 to get our 60-degree cone. So here we go. So there's 30 here, over, touch, and then 30 degrees out and over. And this will get us to the point where this freaks some of my students out here at the university, in Northern Kentucky University, is that they start to see this cone here, the vertical vanishing point starts to dip inside the cone. And that's a good thing, because that means we're getting closer to 90 degrees, which is going to give us more of a severe angled look, which is totally fine. And when we get to 90, we're back in 1 or 2 point. All right, so I line it up along my cone here and just draw through. Now we know where our distortion is going to happen outside the cone and where less distortion happens in the cone. Okay, and then what do we need left? We need right vanishing point, left vanishing point. So let's go ahead and get our right vanishing point in first. I'll put it about right here. RVP, right vanishing point, and the only thing we have left is our left vanishing point, and that is got to be made from the vertical vanishing point, which is right here, right there. Make sure you know that. Vertical vanishing point, construction line through there, okay? Now remember, 90 degrees from that construction line back to, and I hope I don't get outside the screen. I might actually, yeah, I probably will outside the paper, that's okay. So from the right vanishing point, construction line here, out through the center point along the eye line, out and down, and I might, let's see if I can keep it on screen or on paper. Probably not. I got close. Darn it. Oh well, it's okay. So I'm going to come out a little bit. Yeah, just barely. So I'm going to put, let me see if you can see that. I'm going to draw over with a white pencil. Yeah, you can see that. There's the horizon line, and then there's where my line to find my left vanishing point is. Right there. And there we go. All right, so there's my LVP. Yeah, you can see that, just barely, but there's my LVP right there. LVP. There we go. A little bit off on the paper. That happens from time to time. No big deal. So remember, that's a 90-degree relationship there. Draw lightly through here. 90 there, 90 here, and then let's go ahead and prove that from our left vanishing point through our vertical vanishing point, our construction line back through our center point along our eye level is also now at 90 degrees back to our right vanishing point. So we gotta go a long ways out here. There we go. And that'll get us through our center point and then on down, and we're good to go there. There we go. Bingo. And we've got it. Okay. So there's our 90-degree relationship. Now we have everything we need. We have our left vanishing point hanging out way over here. We have our vertical vanishing point inside our cone, which is kind of cool. And then we have our right vanishing point. So we know where to go now with our drawing. Okay, so let's draw now a 65-degree cube looking up. We're down the ground. We're looking up at 65 degrees. So I'll draw vertical diminishment coming out a little bit. To catch that in, I think I'll put the top here and the bottom about right there. Okay, then I'll make that in blue so you can see that stronger right through there. Now we need to project our diminishment back to our left and right vanishing point. So here's our left, out this way, left, out that way. I'll put little arrows to show that right through there. And also diminishment now to the right vanishing points. Here, arrow there, and also out there. There's another arrow. Okay, so now it becomes a design problem. How far over do you want to make that box? I'm going to come in a little bit so you can see a little bit better. Let's dig in there. There we go, and I'll pull down so you can see the other drawing kind of through it to see how these look different. All right, so we have that. Let's cut off the box about right here. I'll put a dot there and then draw back to the LVP and then color that in or make that stronger. And then from the vertical vanishing point out, look at the angle of diminishment, really strong there. Now, right through there, tone that through the blue. And of course these connect back over, so we've got our left plane with our 65-degree cubic box. It's kind of rectangular looking, just fine. Now, how far do we want to make it over here? I'll make it a little bit farther. I'll put a dot there and say I'll go a little bit farther. I'm just relating from this length to that length just to get that, and then back to. Then from the VVP outward to the box corner, draw that arrow so you see that coming out. And then we're good to go there, and then over and downward there. Okay, and then we line up from our right vanishing point out to end our box in our corner there. And now we just need the bottom. Now we're going to be seeing a much flatter view of that bottom of the box, which is what we want at 65 degrees. So from the left vanishing point through this corner out, right? Do the opposite here from that corner through the right vanishing point. If I go fast, pause me, slow me down. You can do that, no problem. Right in through there, and then we find the bottom of our box, right? In there. There we go. Now, let's go ahead and find through the box, and so we can get 6 sides. Through there, we'll project back to the LVP. Then this corner back to the right vanishing point. I'll draw through pretty good so you can see those arrows coming through. Where they meet up, there's the corner of the very top as if we're drawing glass, and then through this corner, line up the vertical vanishing point right through there, and it will touch right in through here. And now you have your 6-sided boxy kind of cubic form. That's a 65-degree angle now. Now looking through up to, at 65 degrees, this boxy kind of form. Rectangular form. There we go. I could have cut it off maybe here to make a true cubic-like form. There we go. Later on I'll show you how to get 45-degree measuring points so you can get true cubic kind of boxes. Right now we're just getting the setup. So let's take a look and see and review what we did. Let's pull out a little bit and let's take a look now. So that's 65 degrees in worm's eye view, looking up at 65. That's pretty severe. Notice that the vertical vanishing point is inside the cone, right? This could keep on coming and get to here, and we get to 90 degrees. We get a flat 1-point box look. Okay, so we're at 65-degree tilt. Also notice what that does. That gives the rate of diminishment a very angled, distorted 3-point view. This is very accurate to 65 degrees. We're starting to get further and further underneath as our head goes up at 65, looking down. Now we have at 45. Look at slightly the difference between here, okay, and here. Take a look especially at the bottom. This is important. We're up, tilted even higher. This becomes even flatter, and this becomes more angled because it's slightly closer to the horizon line, and we're only at 45 degrees. The vertical vanishing point is pushed up higher, so these angles are not as severe as these. Look how much further that's tilted. 45 degrees. Now let's go lastly to 20 and look at the contrast between the other two down here. And we have 20 degrees. Our vertical vanishing point is pushed much higher because we're at a 90-degree relationship from our vertical station point, right? Right in through here, which pushed that VVP up very high, meaning that our rate of diminishment here is much less steep. You could be 3 degrees, 2 degrees. When you get less than 15, maybe less than 10, if you will, 3-point perspective, you might as well go to 1 and 2. Because you want in 3 at least, I think about 15 to 20 get you pretty nicely. So again, the relationship from the VVP right to our eyeline center point, and look at that slight view of the bottom of the box at 20 degrees. Our head is not tilted. We're only at 20, tilted up. Now we start to go further, tilted up at 45, and then we tilt up pretty nicely, pretty high at 65. And if anything beyond 80, maybe 75, probably you want to, it just might as well go back to 1 and 2 point, looking straight up. Okay. All right. So there you have your setup: bird's eye view, worm's eye view, finding your 4 areas that you need: your vertical vanishing point, your left and right vanishing point, your vertical station point, which gets you your eye line. Remember, those are different than your 4 fundamentals. Your 4 fundamentals are what? Your horizon line, eye level, your center of vision, your cone of vision, and your station point. So there's a little change there too. They both work together. Okay, the next diagram I want to show you is going to be these head tilts, and again what these boxes look like at these head tilts, to really get you the concept of 3 points, so we can go on very quickly and soon to more complex studies in 3 point. Okay, hope you enjoyed it. Practice this setup constantly. If you spend 10 minutes a day, do little bitty drawings, little thumbnail sketches, do 3 or 4 worm's eye, 3 or 4 bird's eye, so you remember this process. Be able to memorize the 1 point setup, the 2 point setup, the 3 point setup. Dancing hands, right? You're gonna be strong with this. It takes a little memorization. And if you keep a good sketchbook, if you later on, if you don't use 3 point for a while, then you're like, hey, how do I get that set up? Go back to your notebook and you've got it. Or you'll always have my videos too as well, if you need. Okay, there you go. Thanks a lot. I will see you very soon with the next diagram. Take care. Bye-bye.